So, like I had mentioned before, the reservoir is so large that they're thinking, well, we can maybe start bringing in CO2 from other sources and putting it in. There's a 420 megawatt natural gas power plant in Norway, and this is, right now, it's emitting 1.2 million tons of CO2, or this is the potential that they could be capturing and storing in the reservoir. So they're estimating that in the year 2011, 2012, they're going to start actually moving the CO2 from the land-based power plant out to the platform for injection. Phase one, to begin in 2012. You can see, here's the power plant I've been talking about, and there's a few other CO2 capture facilities spread around the land here, and here's some reservoirs out in the ocean. And they're thinking of building pipelines to these reservoirs so that they can inject. And the project is planned over a wide spread of years, so there's a phase two of the project is eventually connecting more of the power plants on land. And phase three would be an interconnected grid network where they can exchange CO2 capacity with each other and move it around to where it can be deposited most readily. Potential basin characteristics for something like this. So if they were looking to expand this technology, they would be looking for stuff like porous reservoir rock, like a sandstone we've seen today, tight cap rock or a shale, kind of trap it in the sandstone reservoir. Sufficient depth in order to get the pressures needed to keep the CO2 in a trappable state. Accessible topography, so they want to be able to get to the point where they can actually inject the CO2 into the ground, and then a large volume reservoir so that they can basically put as much as they need. Examples of this in Mexico, the Gulf Basin, and the Naylor gas field in southwestern Victoria, Australia. These are two reservoirs that kind of are modeled similarly to the Sleipner field and could be used for the same processes. As you can see, we saw this in the lecture. The darker areas are the highly prospective sedimentary basins, and so this is where your Gulf of Mexico would be around here, and then the Australia one is sitting right down here. Is that little black dot you see on the bottom. And so the moral of the story is that the Sleipner field equals carbon capture. And there's our mythological beast. Is there any questions?